Welcome to WIT, where I type. Episode 1. Today we'll talk about TDD and about parsing. TDD is a method that you write tests before you write the functionality. This has 3 key benefits. The first one is that you will have quite good test coverage, because if you always write at least one test for every feature, it's very likely that one of those tests will signal if someone else breaks that functionality. The other thing is the motivation. When you feel that you have completely written so that the test passes, because they first write the test so it fails, and then you implement the code, then you will feel this kick that you have done something correct. And that's important as a programmer, because sometimes your work can be very I don't even find the words. Anyway, moving on. The third part is that it helps you with design. Because of that, you write the test, you actually use the function before you use it, before you write it. And by that, you can figure out how do I want to use it before you actually create it. Because sometimes you write your code and then you're trying to use it and like, this is so hard, so many parameters. What should they do? It gives some kind of easiness to how your interface and API looks like. So for the TDD part, we'll use a tool in Python. It's called doctest, which is a really easy way to write tests. It's a way that you write test by example. So in the document string, and if you don't know what the document string, you will learn that too, what it is. So in the document string, you actually write how you use the function as an example. And the doctest utility will find those parts of the document string and try to run them, and run them isolated so you don't destroy anything else. And then it will see that they work. And if you return something else than you wrote, it will say that it was a failing test. And it's kind of what you need for TDD, especially if you do unit testing. If you need bigger test cases, then you're probably doing it wrong if you think that they are unit tests anyway. So it suffices, especially for this kind of simple program. So other tools I will use Vim, and I will use Git. Git is a version control system, and I will use it primarily to save what I have done so that you can check it in text if you don't want to. And you don't need to know Git to use this. You only need to go to GitHub, where I will put this up probably a little bit later than this video, but anyways. And then you can go through the history of changes that I do to the code. You'll also see a README there with what the assignment is about and how you would go through step by step doing it. There's quite big steps, but anyway. So now a little bit about parsing. And if you already know about parsing or you just want to go ahead, do so. Don't listen to my babble here. But the parsing usually are a way to translate one text to something else. So usually it's part of a compiler, but it can also be a way to parse input, a command from a user, or a file from the hard drive, or maybe a packet from a socket from the internet somewhere. Only if you get something in text, you usually do some kind of parsing, even if you don't know it. The common way to parse things is to start with a lexer. A lexer, L-E-X-E-R, is a program that takes a text stream of some sort, probably can use some other stream than text, and go through character by character and finding parts that it groups together and says, okay, this is an entity, this is a token. Token usually have some more meaning than just being that type, so it can have a value to it. We will have 4 types of tokens, no 5. we will have numbers and we will have operators, and the operators will be split into 4 types of tokens. So we'll have numbers, which is values, and they will be represented by their value, and we will have the plus, minus, times, and division, and they will be represented by their characters because they're single characters. So that part will be quite easy. We just try to first divide the expression, which will need to be white space separated because we don't need to do any regular expressions or anything, because we'll keep this simple. And then we'll give that to another part of the program. And that other part of the program is an AST builder. AST stands for Abstract Syntax Tree, which is a way to group these tokens and to give them a relationship to each other. To let them relate to each other. And a tree is a very simple data structures where you have nodes which have other nodes, and it's always pointing somewhere. So you have leaf nodes which has no knowledge of anyone else, and then you have nodes in different layers up to the the root node, which is the one that has a relationship to everyone going through the other nodes. So one node has many children. If it's not a leaf node, then it has none. We'll have 2 types of nodes. We will have value nodes, which will just be the value. It will not be some other kind of data structure. And then we will have the operator node, which will have a left child, a right child, and then the no value, which will be the operator. And recursively upwards, we'll have the final operator node, or if we have a simple expression, it will only be a value. And a mathematical expression of the type that we will parse will have 2 types of operators, and one of them are important that they are done before the other, and that's division and times. If you have both division and times, it doesn't matter, because they are interchangeable, the order. But if we have 1 plus 5 divided by 3, it's important that we do the division before the addition. So that means that the multiplication will be lower down the tree chain and the addition will be higher up, because we do it from bottom up, because the values are already calculated, and then we go to the root, to their parent, and do those calculations. And that was actually part of the evaluator. I had a problem with saying that last time I tried this. Anyway, so we'll need to evaluate the AST, and it will do what I already said. It will go through the tree and do the different operators, and then in the end we will have a value, which is the return. And last but not least, we will build the interface for the user. This will be a command line interface, which will just take the string that you give as a parameter, and it will try to evaluate it. So that's it, and I think I finally did this, and we can move on and see you on the other side of the screen where I type WIT. Bye.